Okay, so we are going to start the learning outcome 3 of network design, and Lawrence is available, and we expect the Abid as soon as he will join, and he will be able to participate. Network design, be able to build a network to meet a client brief. So if we look at the indicative contents of the learning outcome 3 in the network design, it says be able to build a network to meet a client brief. It means, for example, if we assume that we have been asked to build a network, create a network for someone, then obviously we need to look at the requirements as well as to find a solution. So assessment criteria wise, you are looking for to build a network to meet a client brief. Network, they test the network against requirements of the test of the client brief. So obviously whatever the requirements you want to fulfill, then you need to check whether they are being fulfilled or not. You need to test it as well. You need to evaluate the performance of any of the issues for which you build the network against client brief, and obviously you need to recommend the security requirements as well to keep the network safe and secure from unwanted cyber threats and attacks. So what we will be discussing today will be the architecture of the network that you will be proposing to your clients. You will be proposing the network testing, and that would be including the objectives of network testing, criteria for network testing, testing results, and then how you would be checking the performance. Let's say you need to select the performance criteria, you need to measure the network performance, and you need to look at the security of the system of the network, let's say, which might include the network auditing, dealing with the network threats, security measures, security policies. So let us start with the slides. Network architecture that you will be proposing to your client, and obviously you have a wide variety of the network types like a LAN, WAN, WLAN, main, SAN, chain, PAN. We have already discussed these type of the networks in previous slides, and then depending on the requirement, you can propose your clients for the use of particular type of the network, and each network is obviously has certain advantages and disadvantages. Certain theoretical description is also given in these slides, and their uses, and we can always use them in more detail, but since we have already discussed those, over here we are only required to propose a kind of network according to the client need. So obviously the type of the network would not be extended beyond the kind of local area network. Possibly your net client may be looking for a network of networks, like a wide area network. Their branches might be spread into more than one building, or maybe out of the city, maybe worldwide. So depending on the need, you can propose them any kind of the network. Like you have a variety of the networks: metropolitan area network, storage network, WAN, LAN, internet based. So everything can be possible. It is your responsibility to propose them a sustainable solution for their needs. And obviously, if it is a network and it needs to have a kind of topology, the physical structure. A network topology is the arrangement of a network, including its nodes and connecting lines So you need to look at the network topology as well, that what would be the topology used for your solution. There are two ways of defining the network geometry. Obviously, we discussed earlier the physical topology or the logical topology. So it doesn't mean that whatever the physical look is given to you, obviously the logical can be different. So you need to propose the network, type of the network, the topology as well. We discussed the different type of the topologies like a bus, token ring, mesh, star and tree. And obviously every topology has some advantages and disadvantages. So we have already discussed these topologies in previous lecture. We will go further onto the next slides. In the network design, you are going to propose the physical infrastructure to your client brief. In your proposed design, you are going to propose the physical infrastructure. The network infrastructure refers to the hardware and software resources. So whatever you are going to offer a solution to your clients, you are proposing the use of hardware and software resources of an entire network that enables the network connectivity, the communication, the operations and management of an enterprise network. So in order to provide a solution, you are required to provide them the network type, you are required to propose them the topology, as well as you are required to propose them the infrastructure as well, and the infrastructure can be the hardware as well as the software. The network infrastructure provides the communication path and the services between users, processes, applications, services and external network or the internet. So these are the main concerns that you are going to propose to your client according to their client brief. The infrastructure, network type, topology. Normally, the physical layer defines the electrical and the physical specifications of the devices. If you probably look at the previous slides, then every network is represented is defined, is described, having certain kind of logical or model, the OSI model we discussed earlier. So the physical infrastructure works at the physical specification of the layer. In particular, it defines the relationship between a device and a transmission medium. So the infrastructure in a whole will be the device that would be connected with the transmitting medium, like a wires, cables, wireless, whatsoever, or the copper cable or the optical cable. So infrastructure is must. You need to be very much knowledgeable about it, that how and what kind of the hardware and softwares would be used in the proposed solution. This includes the layout of pins, voltage, cable specifications, hubs, repeaters, network adapters, host buses, adapters, and many more. Whatever the networking equipment would be used, its main task is the transmission of a stream of bits over a communication channel. So for the proposition of a network solution, you should also have a good understanding and the knowledge of the equipment in the form of hardware as well as software available, so that you as the network administrator or the solution provider should have a variety of knowledge, as well as you should be able to provide them a confident solution which should fulfill their requirements. And obviously you for your assignment brief, you should be able to give a proposed solution by looking at the network types, topologies, physical, the devices and the softwares we discussed earlier, like switch, hub, repeaters, and these things. they really need to be explained, their uses and how you would be deploying those hardware and software. Now, it is important, we are going to discuss the network testing. Earlier we were talking about the network design, the architecture that you would be choosing for them. Now you are going to test the network. Obviously, you deployed your network, you installed your network by choosing the hardware, software and the network types. Now, if it is in use, then you are going to test it as well, that whether it is performing well or not. So, network testing. So let us see what is the network testing. The network testing is an investigation conducted to provide stakeholders with information about the quality of a product or service under test. So this is about a test. Then the network testing can also provide an objective, independent view of the network to allow the business to appreciate and understand the risk of network implementation. So whatever the network has been implemented, you need to know that is there any risk in the network, is there any need to test the objective of the network. So the objectives of network testing is to develop the theoretical basis for network testing. So network testing is being done based on the theoretical concept that the way it would be tested, and obviously to define a methodology and build tools that support cost-effective testing. So the testing of the network would be done by a methodology and by using the certain tools to get the effective testing of the network. The task of network testing addresses the problem of verifying that a network built from components works correctly in concert to provide required services. So, what is the object of network testing? It addresses and verifies that the network, whatever you have built, works correctly against the required services. In connection with the required services, whatever the services you are expecting, and the network is working according to your needs. So in this way, you need to know the objective of the network testing and you need to get it tested, and then you will be evaluating your network that how well it is performing. So the testing itself, testing of the network would be based on certain criteria. If you have a kind of a criteria, then you can test the network and get the results. So effective testing of a network has a number of prerequisites. For example, the testers must know what the network is required to do. And you cannot test the network that against, without the requirement, you cannot test it. If you don't know that what is required to run on the network, then you won't be able to test it, that whether it can run on the network, it can be adjusted into the network or not. Otherwise, for example, if the network has a capacity of, let's say, 10 gigabytes per second, and you don't know that what network is required to do against your requirements, then you cannot test it. So, being a tester, you need to know what is required to do on the network. Then you really evaluate it, that whether the required functionality is achieved on the network or not. So that's about the first point. And then the testers must develop a plan for determining whether the network does what it is required to do. So the plan itself is most important. It cannot be the case that if you are not using the network and you are going to test the network. But however, you should be very much clear that probably the testing of the network means the usage of the network at the time of its peak usage and its normal usage, its minimal usage, whatever the usage percentage is, you should have a plan to test it. Probably you can say that with the minimum data, it has to get some kind of values, let's say a minimum values. Then certain testing results at the average usage, and then certain tests may be taken at the most usage of the network. So whatever needs to be done, that needs to be done under a plan, that at what time you will be doing a particular test. Otherwise, you won't be able to test the system, right? And next is, testers must be able to mimic end user activities and sometimes must be able to mimic some of the network elements if they are not available during the test. So it's not the case that you would be able to test the network as a whole as a tester, but no, it cannot be the case that the usage of the network, the capacity of the network could be tested by certain simulation tools or anything else. But if you really want the network to be tested, then you will have to mimic the end user. You will have to create a dummy user of yourself. Then by using the mimic user, a dummy user, you are becoming a user of the network, and being a user of the network, you would be assessing the network. You would be assessing the network, and the assessment of the network will give you the results that you expect with your real users. Whatever the results of your real users will get, in the same way, for being a tester, you mimic to be a user, and then you can realize that how the network is performing well. So it's about a kind of guidance that you need to be a good tester. Then testers must be able to determine what the system has done in response to their activities. So obviously the aim of the testing is to know that what the system is doing against the activities. Whatever the activity is supposed to be done, then you expect the kind of response on the network. Probably you do not get the expected response, but if you get the expected response, then it is against the particular activity. So this is kind of the hint to the tester. Then testers must be able to measure the effectiveness of testing done so far. So the criteria of the testing should be very much clear to you. Otherwise, you won't be able to know that what really you want to achieve. For example, if you want to know that you need a performance above 80%, okay? If it is above 80%, then probably you need to measure and you need to calculate the effectiveness of your own desire. For example, if you think that if the network performance is above 80, then you would say that network is effective, your test done is effective, the measure would be satisfied. And if you think that you are not getting the particular threshold of the testing results, then your test is something else, and you do not qualify, or your network doesn't qualify for the particular performance. So this is about the general things about the testing criteria and their testing results. Your network testing would be dependent on your requirements and the expected results over the network. So it's about the testing criteria and the testing results. You propose your solution to the client brief, and then you tested the network after analyzing the requirements, and you created a criteria, and after creating a criteria you did some test, and then when you compared the expected results and the given results, and then you seen the difference and you seen the effectiveness of the network, and then you concluded that what performance of the network you are achieving. Now furthermore, the testing of the network and its performance criteria and measures are based on certain constants. Let's say if you want to know the performance of network, then following measures are often considered important. Let's say bandwidth, throughput, latency, jitter, error rate, and these are the measures. So bandwidth is commonly measured in bits per second, is the maximum rate that the information can be transferred. So if you remember that in the last slides we discussed about the bandwidth in detail, that how much the data can be carried out through a medium per second. So probably it could be the digital into the bits, and if it was a bandwidth used in the signals, then it was measured into the hertz, cycles per second, the frequency wise. And the throughput is the actual rate that the information is transferred. So in the bandwidth, how much information is measured is transferred, and the throughput is the actual rate the information is transferred. The latency is the another measure for the network performance. The latency is the delay between the sender and the receiver decoding it. This is mainly a function of the signal travel time and processing time at any nodes the information traverses. So latency is the delay, how much delay is in the network transmission. Probably you must have seen this latency word into networking when you are trying to access any kind of server, or if you are doing any speed test, then you really see this term, that how much delay is between you and the other device. Jitter is the variation in the packet delay at the receiver of the information. So probably whenever you send some information, then if there is any kind of delay at the receiver side, then there is a jitter. If the device is not ready and there is a delay for the receiver, then it is called the jitter. The error rate, the number of corrupted bits expressed as a percentage or fraction of the total sent. So it's not the case that every time you send any message or data in the form of packet, then it arrives without being lost. No, every time you send some data in the form of packets, then you expect some kind of data packets to be lost. So really depends that how much error rate it is, then probably as much as the medium is strong, you get the more like a less number of errors. For example, if you are using the Ethernet cable for the network, then you get you get a kind of loss into the data or the frequency, and if you are using the fiber optic cable, then you have a less number of the decay or reduction or the loss of the data. That's why for example, the high speed networks, you are always recommended the fiber optic cable. So fiber optic cable allows you to transfer as much as data, as well as it has less number of losing the packets. However, the conventional copper wires like in the Ethernet, they have more, let's say the loss of data while transmission. Some more explanation about the bandwidth we discussed earlier. Throughput was the concept of actual day rate the information is being transferred, and then the jitter and the error rate, they are explained in these slides a little bit more. So you can always go through these slides. We try to move further to some other slides. And as the name, these are a simple explanatory the definitions. Let's say the available channel bandwidth and the achievable signal to noise ratio determine the maximum possible throughput. Throughput is the number of messages successfully delivered per unit time. So as these are the little definitions about short definitions about these terms, and these are the bit more detailed definitions. So we move further on the next slide, and you can always repeat these definitions into more detail. Now we talk about the network security. So far we were talking about the network testing, and the topic we discussed was the network design. So now we are on the third topic of today's lecture, is the network security. So we started with the network architecture, then we discussed the design, then we discussed the testing, and the fourth one is the network security, that how you would be providing the security to your proposed network solution. Yeah. So started with proposition of the architecture. You gave the architecture, then you gave the design, and then you tested the solution. You tested the proposed network architecture, and then obviously, in order to make the network secure, even if it is performing well, and if it is not secure, then obviously your network is at risk, and you haven't done very well with your networking. So the topic in the network security is the network auditing. The network auditing is a process in which your network is mapped both in terms of software and hardware. You are trying to see that how the network is doing well using software and hardware. The process can be daunting, scary if done manually, but luckily some tools can help automate a large part of the processes. The administrator needs to know what machines and devices are connected to the network. You want to audit the network, that how is everything going well or not. What happens if the network is not secure? Then according to the audit of the network, the things won't be doing very well and you get the unexpected results, or you get the modified results, or you get the malfunctioning results over the network. So it is the responsibility of the network auditing to know and to see how the process is going through using the software and hardware. And obviously it is very difficult, it is very daunting scary, impossible to test the network that what's going on manually. You cannot do it, but obviously certain tools have been designed for the network monitoring that make the life easy. So administrators need to know what are the machines and devices connected to the network and how they are working. Possibly the simulation devices, network monitoring devices can also be connected to the network in order to audit the network. So let us see that how your network is open to threats and what kind of threats can happen to your network. Potential attacks, software and platform vulnerabilities, malware and misconfiguration issues can pose serious threats to organizations seeking to protect private, confidential and proprietary data. So, any attack on software, platform vulnerability happens, any malware or any misconfiguration issue, if it happens, then it is a threat to the organization where someone is trying to get the protective, private and confidential data. So fortunately, various technologies collectively known as Unified Threat Management, also called as UTM, make it easy to use appliance-based tools to provide thorough and comprehensive security coverage. So, like they are working together, UTM, they are providing a kind of appliance-based, a kind of integrated solutions, kind of integrated comprehensive coverage to the network threats. So typically, UTM solutions bundles a great many functions that includes, for example, proxy services. What does the proxy services do? To block revealing details of internal IP addressing on networks and to determine and or examine communication and data transfers at the application level. What happens in the proxy servers? If you are using the proxy server, then most of the details will be hidden from the within the network while they are traveling. For example, if there is no any proxy and you are communicating from your home to another network, maybe in another city, then through the network, someone can easily know the detailed IP addressing of your network, your communication, that from where you are communicating, what is your IP address and how you are communicating, how often you are communicating, which ports you are using. But if you are going through the proxy service, then probably that service will hide all the details of the IP addresses and the locations, that who you are and from where you are using or accessing or participating into the network. Then another inspection, that's called the stateful packet inspection, to distinguish the legitimate network communication from suspect or known malicious forms of communication. So, stateful packet inspection is a kind of diagnosing the legitimate network communication. For example, the way you should receive the packets of your message. Normally what happens, the data when you are sending from one place to another place, it travels into the form of packets like a kind of in the form of bits of the group of bits. They cannot, let's say if you say that you are sending a 1 MB file to someone, then you cannot, let's say, that pass it as a 1 MB over the network, but every time it will be splitted into the data packets, really depending on the size of the network and the application. It's divided into the packets. The arrangement of the packets possibly could be compromised, like the state of the packet, that it would explain that how the packet is coming, and if there is any distinguishedness, if there is any something different way of receiving the packets, then you suspect kind of malicious work. So how you check? You check the statefulness packet by the inspection. Then there is the deep packet inspection to enable the data portion or payload of the network packets to be checked. The facility not only enables protection against malware but also permits data checks to block leakage of classified, proprietary or private confidential data across the network. So it's not only the case that the packets are received delay, but you can also check that whether the packets have been opened, is there any data leakage into the packet, somebody tried to read it. That kind of the inspections basically really give you an idea that whether your network is secure or not. If your network is not secure, it doesn't mean that you definitely need the security, but if you think your application is secure, is confidential, like you are an enterprise, then at any point at least some of your enemy would try to deceive your network and try to harm your network. Otherwise, for example, if there are no chances of any harm, threat from any user, then probably you could safely communicate over the network without providing the security. But unfortunately, behind any of the usage of the network, somebody is to be considered some harmful. That's why you provide them a kind of secure network by providing certain criteria like a proxy service, stateful packet inspection, deep packet inspections, and these kind of tricks that you do. Obviously, this is kind of a very technical work, but how it is done, what it is called, these are the terminologies. Then real-time packet decryption, then obviously the decryption is a kind of encrypted messages to be de-encrypted. How? The decryption exploits special hardware which essentially reproduces software programs in the form of high-speed circuitry to perform complex data analysis to permit deep inspection to occur at a real network wire speeds. So it's not only the case that you are using only the software to test the network, but real-time packet decryption, by using some special hardware, it gives you a very faster and effective way of identifying the problems that can occur into the transfer of the data at high speed circuitry. Email handling, which includes the included malware detection and removal, as well as spam filtering and content checks for phishing, malicious websites, and blacklisted IP addresses and URLs. Probably you must have noticed that nowadays, not only nowadays but since long time, there has been kind of viruses being sent into the emails, and in initial times the email providers like Hotmail, Gmail, Yahoo, they were not efficient enough to identify any viruses into the email. But nowadays, you must have seen that every email you receive, then you get also a notification that the attachments have been sent to you, or the attachments that you have received have been scanned first and then being given to you. So that particular email handling not only checks for the antiviruses, but it checks for any of the possibilities of the phishing, malicious websites, or many more kind of like email threats you can be faced, includes the email handling. Intrusion detection and blockage. Intrusion is basically sometimes the data is intruded. You are receiving the message, but somebody is adding their own data into the message, so it's kind of the intrusion detection. You are going to detect the intrusion. Has somebody else modified the kind of data? Then application control or filtering, which observes the applications in use. So not only the kind of communication, but the applications itself are being observed, especially the web-based applications and services, and apply security policies to block or stop unwanted or unauthorized applications from consuming network resources or accomplishing unauthorized accesses to the transfer of the data. So it's not only the communication is to be secured, but the devices or the applications also needs to be secured so that they cannot be used or malfunctioned or misused for any of the purpose. Virtual private network or remote access devices enable remote users to establish secure private connections over public network links, including the internet. Most organizations use such technologies to protect network traffic from snooping while it's en route from sender to receiver. So for example, you think that for example the banks are connected. If one transaction is being done from one branch to another branch, then you don't expect that they would be talking or the communication they are sending through the normal internet, but no, they have a VPN, virtual private networks. Nobody else can enter that particular VPN into the part of the VPN even to listen to the secured information. For example, you send a transaction to someone, you wanted to send money to someone, then how much money you are sending, obviously the information will be encrypted with some techniques. If it is being done into the VPN, the virtual private network, then the intruders, the hackers even won't be able to see the encrypted transactions as well. While if it is going through the normal internet and the communication is secure and encrypted, then possibly the hackers could access that particular encrypted packets, and probably they might take the years and years to decrypt it. However, using the VPN, virtual private networks, your transmission is going through and pass through a very private network where nobody can enter the network or even read or listen to the even encrypted data. So that's about the VPN. And other security measures you can use, like introduce the firewalls, antivirus systems, intrusion detection system, patching and updating, general network tools, port scanners, network sniffers, vulnerability scanners, and these things. You need to have a security policy. A network policy is a generic document that outlines rules for computer network access. It determines how policies are enforced and lays out some of the basic architecture of the company security network environment. So if your network is secure, you have some security measures, then they needs to be applied according to the security. The document itself is usually several pages long and written by community. Security policy goes far behind the simple idea of keep the bad guys out, but the very complex document means to govern data access, web browsing habits, use of passwords and encryptions, email attachments. It specifies these rules for individuals or groups of individuals throughout the company. So it's not only the way that your network is secure, but the policy. For example, if you think that some of your employees can reveal the privacy, they can expose the privacy, they can expose or provide the username and passwords to anyone else, then obviously you cannot stop them, but you can have some policy that every time your usernames and passwords should be changed. For example, every day the employee of the bank is getting a new password, and after 5 p.m. once they are leaving the branch, then the password would be automatically be changed. So it really depends on the policy, what policy allows you to be more protective for the measures of your network. Yeah, so that's about the so how is the Lawrence, do you have any questions?
I'm with you.
Sorry?
I can hear you. Did you say what?
Okay, so I stop the recording now and then we can discuss more about these slides. Yeah?
Okay.
Okay.